Hello students, welcome to my channel Explore Physics, Let's Explore. I hope you all are doing well. In the previous class I have explained you about the rays which are to be taken to draw the ray diagram. Today we are going to discuss the image formation by spherical mirrors. So without further delay, let's start the class. I'll be explaining you first about the image formation by a concave mirror and then by a convex mirror. So the first is when the object is at infinity. So the position of the object is at infinity. So we'll see what kind of image will be formed. So here we have, when the object is at infinity, say this is our concave mirror, and say this is P, the pole of the mirror. This is, say, the principal axis which goes through C. So this is C and this is, say, F. So the very first ray, which in the previous class I've explained, that when the object is at infinity, we assume that the rays are coming parallel to principal axis. So here I am taking two rays which are coming from the object which is placed at infinity. And what will happen when the ray comes parallel to principal axis? It will go through F after the reflection. So same thing here for both the rays. They go by or through F after the reflection. And what will be the position and nature of the image formed? What will be the position and nature of the image formed? So what will be the position? At F, at principal focus. What will be the nature? Before the mirror, in front of the mirror. So it's real. Because it is real, it has to be inverted. So it is at F, real and inverted, highly diminished or highly or so what will be the nature and position of the image form? At infinity, real and inverted, highly diminished or point sized. So that is the position and nature of the image formed when the object is at infinity. So when the object is at infinity, the image will be formed at F, at principal focus. It will be real and inverted, and it will be highly diminished or point sized. Second case, and say the position of the object is at F, principal focus. Now second case I am taking where the object is placed at principal focus. What will happen then? Say we have a concave mirror here with the P as the pole. We have one principal axis here which goes through C, and the object is, say, here at F. So I may take one ray which goes and strikes at the surface here. So here we have one ray which goes or which emerges from F and after reflection goes parallel to principal axis. So I have taken two rays from the object O which after reflection become parallel to principal axis. So what is the position of the object? At F. From here to either side of the principal axis I have considered two rays which strikes the surface here and after reflection become parallel to principal axis. So what will be the position and nature of the image formed? It will be, what will be the position? At infinity, we assume that when the rays are parallel to each other, somewhere at infinity they are going to intersect each other. So what will be the position? At infinity, nature will be real and inverted, and we can see from point size object here, it will be highly magnified. Highly magnified. So here we have for the second position of the object, the image is formed at infinity, which is real and inverted, and it is highly magnified. For the third position, I am taking the object at or rather between F and C. Between F and C. So the third case I am taking when the object is placed between the principal focus and center of curvature. Let's see how the image is formed. So here we have P, the pole, this principal axis goes through C, we have F here, and somewhere here between C and F the object is placed. So I may take one ray which strikes here at pole and after reflection goes like this. Take it a little longer. So after reflection goes like this. The second ray I may take which goes through F and after reflection becomes parallel to principal axis. So here we have this becomes parallel to principal axis. So where do they intersect? They intersect here beyond C. They intersect here beyond C and the object is placed between C and F. So when the object is between C and F, I have taken one ray which strikes the mirror at P. After reflection goes making the same angle of reflection as the angle of incidence is, goes like this. The other ray I have taken which goes through F and after reflection becomes parallel to principal axis. They intersect here beyond C. This is C, this is F. They intersect beyond C and the image will be magnified. So what will be the position and nature of the image formed? It will be position will be beyond C that is beyond center of curvature. Nature, it is in front of the mirror, so nature will be real and inverted, and the size will be magnified. So it will be a magnified image. So when the object is between C and F, this is C here and this is F. So when the object is between C and F, the image will be formed beyond C, real and inverted and magnified. This is the third position or the third ray diagram. We have fourth, just opposite to that we are going to take. So when the object, the position of the object is beyond C. See, see students, just notice one thing. What are different positions I have taken? 1, when the position of the object is at infinity. 2, when it is at F. 3, when it is between F and C. And 4th, which is when the object is beyond C. And why I have taken it? Because it's easier to recollect or remember this way. When the position of the object is at infinity, the image is formed at principal focus. Just opposite to that, when the position of the object is at principal focus, the images will be formed at infinity. Third, when the object is between C and F, the image will be formed beyond C, magnified. And just opposite to that, when the object is beyond C. So what will happen? How the image is formed, we are going to see that. So here we have the concave mirror. P is the pole. This is the principal axis. Say this is C and this is F. Now we're talking about the fourth case where the object is beyond C. So see, the object is somewhere here beyond C. So just recollect when the object, just remember when the object is between C and F, the image was beyond C. So now you see, you remember that when the object is beyond C, the image will be formed between F and C. So one ray goes like this, which is parallel to principal axis, goes through F. The other ray, I may take the ray which goes through C and comes back through C only after reflection. And the image will be formed where these two intersect each other. So here the image will be formed between C and F. So what will be the nature and position of the image formed? So position and nature of the image formed, that will be, position will be between C and F. Nature will be, causing it's in front of the mirror, real and inverted and smaller in size. If you compare it with the size of the object, it will be smaller in size. So when the object is beyond C, the image will be formed between C and F, and the nature will be real and inverted, and it will be smaller in size. So remember, when it is at infinity, position is at infinity, the image will be formed at F. When the object is at F, the image will be formed at infinity. When the object is between C and F, the image will be formed beyond C. And when the object is between C and F, the image will be formed when the object is beyond C, the image will be formed between C and F. So these are 4 image formation in case of concave mirror. I'm going to explain you about 2 more positions of the object also. So here we have the 5th case when the position of the object is at C, that is at center of curvature. How the image will be formed, we are going to see that now. So here we have the pole, the principal axis, the center of curvature C, and the principal focus F. Now the object is at C. We'll see where the image will be formed. So again, I'm going to take one ray which is parallel to principal axis. After reflection goes through F. I've told you before also, please don't forget to put the arrows or the direction of the rays. The second ray I'm taking, which is going through F, and after reflection becomes parallel to principal axis. So I'll put this C here. So the one ray which is going through F So I'm going to take the second ray which goes through F and after reflection becomes parallel to principal axis. Where they intersect, the image is formed there. And where do they intersect? They intersect at C. If you just observe it, then we can say that the position of the image formed will be at C, real and inverted and same sized. So when the object is at C, at center of curvature, the image also will be formed at C. It will be real and inverted and of the same size as the object is. So this is the 5th position where the object is at C and the image is formed in this way. We have the 6th position of the object when the object is between F and P. Between F and P, that is between. So we have the 6th position of the object when the object is between F and P, that is between the principal focus and the pole of the mirror. So here I am taking this So this is the concave mirror and the P here and the principal axis. So here, say this is F, this is C, this is P. So object is somewhere here. So what will happen? One ray strikes the surface which is parallel to principal axis and goes back through F. Goes back like this. Through F it goes. The other ray I may take which strikes at P and goes back like this after reflection. So when you produce it backwards, if you see that it's like this way, it's diverging. So it is, I'm going to just take a little more space here. So if I'm going to produce it this way backwards, so they'll meet somewhere here. That is why the dotted line, when I'm talking about behind the mirror. So the image will be formed here. It will be erect and virtual because it is behind the mirror. So this is an magnified. So here, when the object is between P and F, the image will be formed behind the mirror, virtual and erect. This is the only case where the image formed by a concave mirror is virtual. So, what will be the nature and position of the image formed? Nature, virtual and erect. And what will be the position behind the mirror and magnified, bigger in size. So what I have taken, when the position of the object is at or between F and P, so what we have done, when the position of the object is between F and P, the image will be formed behind C. So when the position of the object is between F and P, the image will be formed behind the mirror. Same two rays we have taken. One which is striking at P goes back after reflection in this way. The other which is going parallel to principal axis goes through F after the reflection. So when we produce it backwards, they appear to intersect here behind the mirror. This is the difference also I have mentioned you before, that the virtual images appear to intersect each other where the real images actually intersect each other. This is the only one case where the image formed by a concave mirror is virtual and erect. Now let's take, this is all about the image formation by a concave mirror. All the 6 positions, if you remember the way I have drawn it here or I have explained you here, if it's in the same sequence, it's easier for you to remember. So I hope it's clear to you. Thanks. Stay healthy, stay safe.